Gotta have it plugged in. Okay, so question 9, the cloud height. To measure the height of a cloud, you place a searchlight directly below the cloud and shine the beam straight up. Okay? From a point 100 feet away from the searchlight, you measure the angle of elevation. Well, that's definitely not 83 degrees, 12 minutes, but okay. Not drawn to scale. That's what we're going to slap on this question. So 83 plus 12 over 60 is what? Come on, calculator people. 83 plus 12 over 60. Is that 83.2? All right. Okay, 83.2 degrees. So we want to know how high is the cloud. That would probably be the right side of this triangle. Okay, so which trig function should I use? It is the tangent, right? So tangent 83.2 equals x over 100. This is a proportion, and how do we solve every proportion in the universe? Cross multiplication, thank you very much. Yes, you did. No, stop saying that. Stop saying that. Okay, so there's your answer for that question. Let's copy that. Always check the mode on your calculator, because that ain't it cheap for anybody else. Okay, try that again. 838.6. Do we agree now? Okay, alright. Thank you very much. Let stuff out, man. You can't just hold that stuff back. No, why would he be? There's no reason. The angle of elevation. Is this question 7? Because it looks like you cut off the number. Is that true? It's okay. All right, just checking. I just want to make sure our viewers at home can watch and understand. The angle of elevation of the top. Okay, so angle of elevation of the top of the antenna mounted on the top of the Eiffel Tower. Whoa. So we got the tower. Whoa, why'd it go away? Come on, stop doing that to me. It's not a nose. Tower. Antenna. TV antenna mounted on top of the Eiffel Tower in Paris is measured at a point 185 feet from the base of the tower. Okay. So they basically went over here. Stop disappearing. That is one drawback of this snipping program. So 185 feet away from the base. So notice that it says tower plus antenna. They are not asking me for the tower. They're not asking me for the antenna because I won't be able to figure that out. They would have to give me more measurements to be able to do that, and they haven't. So they measured this right here to be 80 degrees. This over here, 80 degrees plus 1 minute plus 12 seconds. That takes us back. We haven't done that stuff in a couple days. 1 divided by 60 plus 12 over 3600. Can I get a witness on 80.02? Okay. Maybe a day when I take off. Okay. It's reference. Okay. Okay, so we've got the right angle in there. Which trig function would you choose? Man, tangent is coming back. That's interesting. Alright, so let's see here. Tangent of that is opposite over adjacent. It's a proportion, and we cross multiply. Of course, divided by 1 is not going to be all that cool. Or difficult, I should say. So I ended up with 1,051.3. Is that a good one? Okay. What number is this? I don't know. I had to write it in. Not personal. I'll be happy to go back to some of those other ones here when I get a chance, but I need to dive into the Ferris wheel. So please either get out your printed version. Okay, so I'll work on some more of those review questions after lunch. And I'll... Say that again? Oh, okay, I thought you had a question. Sorry. Maybe the name doesn't, but the form does. There is no cool name for it. That's why we made up our own. I mean, like, one of the textbooks that I've seen calls it the graph standardization. It is. There's no good name for it. Shh. Okay, folks. Do we have any questions on how we put it into fireproof form, what we did yesterday? Okay, if you're not looking at the Ferris wheel, you have the Ferris wheel worksheet. That's your homework tonight. You don't have, this is part of the notes. Yes, the numbers are different because I'm not doing your homework for you. Right. Yes, right, yeah, exactly. See, I've already been, I already went through high school. Auctioneer before, but that's a good idea. Yes, we could do, ratings of fortune, spin the wheel, right? No, okay. I mean, we could have all the trig kids from every trig class in the auditorium, playing this giant game show, all these. No, actually, competing for cafeteria prizes, food. 4-8 notes go into the 4-8 section. 4-8, it's at the bottom. 4-8, trig. There you go. 4-8 blank notes. Yes, there you go. Okay, we took a lot of notes yesterday. And those were all the parts of the things. Remember the penguin? Yeah. Okay. All right, now. Any questions about how we got it into fireproof form? The most difficult part being that we multiplied on the right side by 60 over pi. Okay, so help me identify information. What's the... We'll lock it in and change the color. Let's go. A equals what? No, A. A is the stretch on the horizontal. I'm looking at an equation in fireproof form, and you should be able to identify what A is. 60 over pi, thank you. How about B? Say it out a little louder, I thought I heard it. 40? You are correct. The stretch on the vertical is 40. How about H? H. 15. see how we got A, B, H, and K? Okay, what do we use A to figure out? The period of the function. Now, the original cosine function has a period of 2 pi, right? But then we multiply times, yeah, we say the absolute value of A, but this isn't a negative number, so we don't really have to worry about absolute value bars. So, what is 2 pi times 60 over pi? It is 120. Pi's do cancel out. That's true, right? One's in the numerator, one's in the denominator. So you are correct. The pi's do cancel out. Okay. B. What do we get from the vertical stretch? What information about the wave? What do we get? The amplitude, thank you very much. So the amplitude of our wave is 40. Okay? So on the left is a unit circle, but we're going to actually get some Ferris wheel. Okay? And then the graph is right next to it. I need you to attempt to graph the wave. Graph the wave, okay? So, I will help you with one thing here. Your K value, what was it, 45? Okay, that's the line that's drawn right there for you. That big, long, horizontal line is K equals 45. It's not 0, folks. And here's why it's not 0. Because that would mean your Ferris wheel goes underground. It would be kind of cool. Now, if it was like water, and you were like under the water, and then you came back up out of the water, and it kept going over and over. As long as you weren't, drowning.
Wait, I have a question. So is
K is what part of the height of the Ferris wheel? Half the height. Well, it's actually. Yeah, you're on the right track. Okay, when you say half. In other words, the middle of the Ferris wheel is 45 feet off the ground. Okay, now, go ahead and graph this wave. Graph the wave, and then we'll talk about how it relates to the Ferris wheel and all that good stuff, okay? Graph the wave for me. All right, so... Ding, 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 there's my HK. Now, why did I move to the right a little bit of the origin? Why did I move? I guess that's not really the origin. H is 15 seconds. Right? We know that HK is an important location to graph these things. Now, on a cosine wave, is HK on the center line on the way up the hill, or is it under the max? It is under the max. And how far up will you be going to find... that first location, you're going to be going up 40 units, right? Because that's the vertical stretch. 40 is the B value, right? Now, that means the maximum height of the Ferris wheel is what? 85, right? Because you started at 45 and you went up 40. Right. Anybody know where the bottom is? Positive 5. That's true, because if you go 40 units below 45, you get to 5. Okay? Now, how far to the right will you be traveling before you find a place where it starts over again? 120 seconds. So, based on my scale, okay, so that's like 30, 45, I'm hoping I'm not running out of here, but it seems like I'm probably should change my scale a little bit. Yeah, you can make it whatever you want. So I can bump mine over so that doesn't make the children scream. So my HK will be right there, and we said that we would use the amplitude to go up 40 to find the first point. Switch back to my scale. 60, 90, 20, 50. Okay. So if I move to the right, according to what you just said, if I move to the right 120 seconds, where would I land? 135, okay? So 135 is gonna be about right there. Okay, in between those two dots, what's happening? You're completing an entire cycle, aren't you? We could go over another 120 seconds and do the same thing, right? I might not have got my dot in the right spot there. 15 and 135, yes. For those of you who are wondering, this would be 135 seconds right here at the end of that one cycle. Okay, so you did it. Nice job. You're fine. So you went over 120 seconds. I know. Okay, any questions on how we graph the wave? A lot of this should be review. I understand you're using an application. What does the amplitude mean for the Ferris wheel? The amplitude somehow matches a part of the Ferris wheel. What part? We can use it to find the maximum height. It's the radius of the Ferris wheel. Because we stretched it. Now, the 120 seconds. How does that relate to the Ferris wheel? How long it takes to make one complete revolution. All right, so that's the time for one revolution. Unless it's a big country that you're trying to overthrow. Now, let's go back and answer these questions. At the start of the ride, how high is the person off the ground? Do not say 5. Okay, do not say 5 feet. Because you're making a major assumption. When we get on a Ferris wheel, yes, we get in at the bottom, but then we rotate around, and then somebody else gets in, and we rotate it around. So eventually, everybody gets loaded into the cars, and then we start the ride. So at the start of the ride, which is what time? What time do we start the ride? Because the guy goes, what time did he start the ride? 0 seconds, folks. He starts it at 0 seconds. So when we say at the start of the ride, what time are we asking you to plug in? Time equals 0. So we need to use our equation. Now, I don't care which equation you use, whether you use the one we started with. Maybe that would be better to use. So What is 0 minus 15? Negative 15? What is negative 15 times pi over 60? Come on, folks. Doesn't 15 go into 60? Negative pi over 4, right? What's the cosine of negative pi over 4? You should know this from the unit circle. The cosine, let's see, that would be negative pi over 4 is down here. What's the x value? What is the x value? Okay, that would be positive radical 2 over 2, wouldn't it be? So we want 45. Oops, sorry, I can't even type 5. Or I mean, write a 5, sorry. Plus 40 times radical 2 over 2. I bet you probably will reach for a calculator for that, and there's no problem with that because we do want the nearest foot. So grab the machine. Now, could you have grabbed the machine from the beginning? Sure, I wanted to stretch your brain a little bit and think about the unit circle since we had a nice number to work with. But grab your calculator. Which mode should it be in? Well, actually, you don't need to worry about the mode because we took care of it. We took the cosine of negative pi over 4. We just need 45 plus 40 times radical 2 divided by 2. I got 73.3. Is that what you got? So 70 if you try that. So when we started this ride, we were 73.3 feet off the ground. Now, look at my wave. Doesn't it make sense that I was above 45 but below 85? So I started this at 73.3 feet off the ground. Question B, how long does it take the person to make one complete revolution? I got to vote for 120. Do you agree or disagree? You better agree. You just told me that once we did the wave. Folks, if you know the period of the function, you know the answer to the question. What is the maximum height above the ground? 85. Yeah, if you want to put the feet on there, we can. If the ride lasts for 9 minutes. Okay, now how many seconds is 9 minutes? 540 seconds. Okay. Find all the times the person would be at the maximum height. Well, do we know the first one? No, folks, we just said at 0 we would be at 73.3, and that is not the maximum height of 85. What is the first time that we reach the top? 15 seconds, that's right. Oh my goodness, that's the phase shift of the function. That's h. What's the next one? 135. How did we get that? We added the period. Oh my goodness. All right, how do we find the next one? Add the period again. What do we get? 255. Add the period again. What do we get? Yes, we keep hitting the maximum. Every 120 seconds, we're hitting the maximum. Add 120 again. 495. Add 120 again. What? Can we add another 120? Or has the ride ended? The ride never ends. Don't listen to that kid. Sick to your stomach with that. Well, if you look at the screen, 1, 2, 3, 5, right? But you can't go more than 540 because they limited me to 9 minutes on the dot. Right? So we're just, yes, go ahead. Question? Okay, different part of the problem. Yep. That is the angle that we found when we plugged in 0 inside here. So we walked ourselves through the process of plugging in 0, which gave us 0 minus 15 was negative 15. And then we reduced that because negative pi over 6, or right here, right here, it was negative 15 pi over 16. We reduced that to negative pi over 4. And then we knew that was what we needed to take the cosine of. Now, if you are going to do this by just throwing the value 0 in, you would need your calculator in radian mode. Why do I know that I need it in radian mode? Because there's lots of pi's flying around here, folks. Okay? Circular or square, but lots of pi's. Okay? You will need it in radian mode if you're going to just straight up type it in. Okay, any other questions about this Ferris wheel example? Because you have to repeat one on your own. Yes. Okay, go to the fireproof one. Okay, good question. So, we needed to get rid of the pi over 60. That was our biggest issue right here. So we've always talked about, well, we know it's over 1. So what would I need to multiply by to get rid of that pi over 60? I mean, the goal is to have t minus 15. So we decided that we would multiply by 60 over pi, that reciprocal. But if you do it to the top, you also have to do it to the bottom, which is why we got this part underneath. Got another question about this? All right. What's the question? I don't think we have time to start that today. Okay, that's what we're gonna work on this tomorrow. Okay. No, I don't think we're ready for a quiz tomorrow. So I might give you like a take-home thing for the weekend. But I'm not going to give you a quiz tomorrow, okay? Just don't think. I want to dive into this. First thing tomorrow, I want to dive into this. Now, so we'll finish up these notes tomorrow. I would want to switch back. Oh, man. We'll change that to negative radical 3 over 3. Is that going to work? There and there. Now, in terms of pi over 3 is 4 pi over 3. Okay, now look at what they specifically said. They said they wanted x to be in the third, that says fourth quadrant. Okay, now that would be wrong, obviously, since I changed the question. Let's say this was question, 4 pi over 3. So that's question. I'm not going to ask you with a decimal. Okay, let me go find another question for you guys. I have to apologize for the background noise in this video. I got some really disruptive children. Okay, seriously. Okay. The pause for a day will watch boat is located at Point P and is the nearest point on the Baja California shore. Alright, Point Q is located 4.25 miles down the shoreline from now. PL is perpendicular to LQ. Being straight it is. Determine the distance that the pause is from the shore. If angle PQL equals 35. This is terrible. Determine the distance of the radius from the shore. Okay, so I need this side of the triangle. Me. Tan 35 equals. There's people dancing in front of me. I mean, what is going on? Okay. Starting to these videos before I edit this video. Okay. So obviously just cross multiplication. I better check my mode. Yep, my mode's in degree. Nice. So next point. So almost 3 miles. Just a tad bit under 3 miles. Okay, alright. I'll just start this one to get the question. He blocked field goals pretty well. Seriously, that arm range, man. Yeah, not how it used to be, that's true. Yep. Okay, so on question 30, first we're... I did this in the video. How in the world are they asking me this question? Okay, cosine, let's see, pi over 3 is up here. The x value is 1/2. So this question is arc sine, or as we talked about in the video, that's the same thing as sine inverse of 1/2. Okay, so it's the exact same question as this one, if that's what's really being asked of me. Now, we know that, don't do it, okay, that sine inverse spits out angle measurements on the right half of the circle, and if this is a y value, okay, hold on a second, y value, and it's got to go on the right half, so it's going to send me over here. So my answer to this question